Let the given number 6 root 6 plus 14 whole raised to the power 2n plus 1 be expressed as the sum of two numbers k and capital F, where k is the integral part of the number and capital F is the fractional part. Now, since capital F is a proper fraction, therefore it will lie between 0 and 1. Now consider a number 6 root 6 minus 14. Root 6 is approximately equal to 2.4. Therefore, 6 root 6 is approximately equal to 14.5. And therefore, 6 root 6 minus 14 is a proper fraction. That is, it lies between 0 and 1. Now, a proper fraction raised to the power of an integer is also a proper fraction. Therefore, 6 root 6 minus 14 whole raised to the power 2n plus 1 is greater than 0 and less than 1. Now, let's denote 6 root 6 minus 14 whole raised to the power 2n plus 1 by small f. Therefore, small f lies between 0 and 1. Next, consider the difference of two numbers 6 root 6 plus 14 whole raised to the power 2n plus 1 and 6 root 6 minus 14 whole raised to the power 2n plus 1. Using binomial theorem, this can be written as 6 root 6 raised to the power 2n plus 1 plus 2n plus 1 choose 1 times 6 root 6 whole raised to the power 2n times 14 plus 2n plus 1 choose 2 times 6 root 6 raised to the power 2n minus 1 times 14 square plus and so on minus in brackets 6 root 6 whole raised to the power 2n plus 1 minus 2n plus 1 choose 1 times 6 root 6 raised to the power 2n times 14 plus 2n plus 1 choose 2 times 6 root 6 whole raised to the power 2n minus 1 times 14 square minus and so on. Notice that the odd number terms cancel out between the two expressions and we are left with 2 times in brackets 2n plus 1 choose 1 times 6 root 6 raised to the power 2n times 14 plus 2n plus 1 choose 3 times 6 root 6 raised to the power 2n minus 2 times 14 cube plus and so on. This can be written as 2 times in brackets 2n plus 1 choose 1 times 6 raised to the power 2n times 6 raised to the power n times 14 plus 2n plus 1 choose 3 times 6 raised to the power 2n minus 2 times 6 raised to the power n minus 1 times 14 cube plus and so on. Notice that the expression in the brackets is an integer and therefore this whole expression is equal to 2 times an integer, which is an even integer. Therefore, 6 root 6 plus 14 whole raised to the power 2n plus 1 minus 6 root 6 minus 14 whole raised to the power 2n plus 1 is equal to an even integer. Now the first term on the left hand side is equal to k plus capital F and the second term on the left hand side is equal to small f. Therefore, k plus capital F minus small f is equal to an even integer. Therefore, capital F minus small f is equal to an even integer minus k. Now, since k is an integer, therefore the right hand side is an integer as well. And so the left hand side, capital F minus small f, must also be an integer. Now recall that both capital F and small f are proper fractions, therefore they lie between 0 and 1. And therefore it follows that capital F minus small f is strictly greater than minus 1 and less than 1. But we've just established that capital F minus small f is an integer, and the only integer that lies between minus 1 and 1 is 0. Therefore, capital F minus small f must be equal to 0. And so it follows that capital F is equal to small f. Therefore, the product of n and capital F is equal to 6 root 6 plus 14 raised to the power 2n plus 1, which is the value of n, times capital F, which is equal to small f as established above. Substituting the value of small f, we get n times capital F is equal to 6 root 6 plus 14 times 6 root 6 minus 14 whole raised to the power 2n plus 1. This is equal to, in brackets, 6 root 6 whole square minus 14 square raised to the power 2n plus 1. And this is equal to 216 minus 196 whole raised to the power 2n plus 1, which is equal to 20 raised to the power 2n plus 1. Therefore, n times capital F is equal to 20 raised to the power 2n plus 1, which is the required result.